Hi guys, I hope you're doing well and staying safe. As we wrap up our discussion of acids and bases, I wanted to talk a little bit about one of their special properties. So acids and bases have this really cool thing where they can actually conduct electricity, and we're going to talk about why and how that's possible. You should know that strong acids release their own hydrogen ions, strong bases release their own hydroxide ions. Weak acids and weak bases combine with the solution that they're in to cause the solution to break apart and release those ions, which is really important in how they act as what we call electrolytes. Electrolytes are a special type of compound that, when in solution, they conduct electricity. So our acids and our bases qualify as electrolytes because they break apart when they are put into solution. But they do so on kind of a continuum scale basis, where strong acids and strong bases that separate completely, we're going to see they're able to conduct more electricity. This is because when they separate or dissociate, they're putting positive and negatively charged ions into that solution. And that electricity is able to go from one part of the solution to the other as it passes from those positive and negative ions, as it's moving around, so to speak, in the solution. So I have this really cool, what we call conductivity probe, that actually has a light bulb on top of it, so we can easily see if that solution is a conductor of electricity. And in front of me, I have 6 different solutions that we're going to test to see how well they conduct electricity. Now, when we talk about conducting electricity, when we talk about electrolytes and we talk about their strength, you're going to notice that that strength of an electrolyte correlates directly with the strength of an acid or a base. Again, it all goes back to how well do they split apart when in solution. One of the things I want you to keep in mind is that whether or not it conducts electricity and how well it does so can help you determine the strength of an acid or a base. So you're going to see varying degrees of the light bulb being lit here in just a second, but I realized I left the window open, so I'm going to close that really quickly. Okay, so now that it's not quite as bright in here, you'll be able to see the light bulb a little better. And one of the things I want you to do as we're walking through this is I want you to make some notes or make some observations about how well the light bulb is lit. So we're going to start with chocolate milk. So before I put it in the chocolate milk, I'm going to stick my probe into just some cleaning water, make sure there's nothing on it. So now we're going to submerge the 2 probes, this is a positive and a negative probe, into the chocolate milk. And as long as the chocolate milk is a source of electrolytes, the light bulb will light. Obviously, the brighter it is, the more electrolytes or the stronger electrolyte chocolate milk is. So I'll give you a second to take some notes about how bright that is. Next I have pure tap water. So not pure water, but tap water. Hopefully this doesn't surprise you too much. We know that pure water should have a pH of 7, meaning it is neither an acid nor a base. So let's see if tap water is any different. So notice that the light bulb was lit, but not very brightly. That means there are some positive and negative ions in the water, and they are translating electricity, just not as well as the chocolate milk, because they are not as strong of an electrolyte as the chocolate milk. Hopefully that makes sense to you and is fairly intuitive. That as it would be a weaker substance or a weaker electrolyte, it should not be conducting electricity, so it's going to do so to a much lower extent. I'll wash it off just for consistency. All right, next up I have some Powerade. This is pure, regular blue Powerade. We talk a lot about Powerade or Gatorade being a good substance to drink after a workout. So let's see if it is actually truly a good source of electrolytes. Okay, so notice that the light bulb lit, and it lit pretty brightly. That's important. That should suggest to you that this is a good source of electrolytes. Moving on, we have apple juice. The apple juice is also able to light the light bulb fairly well, but maybe not quite as bright as the Powerade did. This lovely solution that needs to be mixed a little bit more is lemon juice. It is pure lemon juice. You may have some pre-notions about lemon juice from some of our other videos you've seen this week. Maybe the cabbage juice video from Mr. Chandler, or the litmus paper video from Miss Lynn. But lemon juice itself is a great conductor of electricity. Notice that this is the brightest we have lit this bulb yet. So that's a good indicator that there are a lot of electrolytes going on here. That also means that lemon juice is probably a really strong acid, or contains a really strong acid. So it has dissociated really well in the solution. And last but not least, let's see what happens as we insert into the pickle juice. Notice that the pickle juice did not take as long to light, and it is very, very bright. So out of all of these substances, our pickle juice looks to be the strongest electrolyte we have. That means that the acid inside the pickle juice, which pickles are made from vinegar, the acid inside that pickle juice has a very, very high dissociation constant, or a very high rate of splitting apart, which is very important when we study our strong acids and our strong bases. And we understand that strong acids and strong bases correlate to strong electrolytes that split apart in solution. And our weak acids and weak bases, much like the apple juice, don't split apart as well, so they don't light the light bulb as much. We could do a lot of these. We could test a lot of different things and create ultimately a continuum of strength from dimmest lit bulb to brightest lit bulb based on the strength of the electrolytes and therefore the strength of the acid and bases involved, if that's what we wanted to do. I do want you to create your own continuum of acid and base strength, much like you will do tomorrow with your pH scale, much like we saw with the cabbage juice colors from pink to black, or that red color to black, and much like you saw with the litmus paper and the various colors from Miss Lynn yesterday. I hope that helps. I hope that was fun. I hope you enjoyed seeing me light a light bulb with all of these different juices that you would find in your home. I hope you have a great day,